Hey everyone, this is Daniel for Rock the JVM, and you are watching a demonstration of automatic dependency injection using pure Scala and its powerful type system. Now, the technique that I'm going to show you in this video comes from Martin Odersky himself, the creator of the Scala language, and I'm going to share the technique with you with his blessing. We're both curious what you think because this can very easily become part of either core Scala or one of the core libraries that come pre-bundled with the Scala SDK. Now, unlike most of the other Rock the JVM videos, I have some code already written because I don't want to type everything before I even get to the main point. And this example comes from my own ZO course because what we wanted to demonstrate here is a comparison between Scala's pure type system and ZLayers. Now, obviously, you don't have to type everything by hand. I'm going to leave a link to GitHub from Martin Odersky in the Scala repo. So here's the example here. We have a fictitious backend that does email subscriptions for a fictitious newsletter, and we have a bunch of services that we want to compose. For example, in order to subscribe some user to our newsletter, we have this user subscription service, which tries to enroll or add this user, defined by the case class with the name and email, to our subscription service. So this user subscription has a bunch of other services, one that sends emails and one that stores users in the database. And in order for a subscription to work, we need to send an email to the user and insert this user into the database by using the injected services here. So we have the user subscription, which depends on an email service and a user database. And the email service has its own API, for example, the ability to send an email, which obviously does just some printing in order to test locally. And the user database also has its own dependencies, for example, a connection pool to interact with an actual resource like a database, and it has an insert method or a CRUD interface. So we are able to use the connection pool that we inject as a dependency to be able to insert this user into a fictitious database. The connection pool itself has a bunch of arguments, and it can spawn some connections to our fictitious database, and then we are executing the queries based on those connections. So we have a bunch of dependencies here. A user subscription depends on email service and user database. The user database depends on the connection pool, and the connection pool has its own parameters, and this may depend further on other services. Now, obviously, if we wanted to spawn this fictitious backend service, we would use an explicit form of dependency injection where we simply instantiate our services and pass them as arguments directly like this. So in order to create a subscription service, we instantiate the user subscription from an email service, user database, and so on and so forth. And the instance here is fully defined. And then we can hit subscribe on users like Daniel at rockthejvm.com and Odersky as shown here. So if I want to run this actual application, we're going to see some actions being taken. So just a moment to compile. And we have, you've just been subscribed to Rock the JVM. Welcome, Daniel. So this is the first user. And in order for Daniel's subscription to be complete, we need to insert Daniel into the database. So we have to create a connection and execute a query, insert into subscribers, values, Daniel at rockthejvm.com, and likewise for Martin Odersky. So in order to spawn up the backend, we need fully formed instances of our backend services in order to be able to use them. But dependency injection is a little bit more flexible than that because we don't really know where the dependent instances may arrive from, which is why we have features like ZLayers in the ZO library that will simply allow you to provide instances that depend on each other, and ZO will take care to map those dependencies via macros. There are many other similar libraries to run the same thing, but I'm going to show you the ZO way of doing things. So I'm going to run an object like ZODI, and this extends ZO app default. In order to run ZO app default, you need to add the ZO library in your build SBT. So if I go to my build SBT, I have dev.zo here, and this is the version that I'm using at the moment of this recording. And in order for us to run a ZO dependency injection, by the way, this is something that I teach in my ZO course, and this example is actually based off of my lesson with ZLayers in the ZO course. So if you want to take a look at the ZO course, you can check that out as well. And the ZODI, being a ZO app default application, will have to override the run method. So override def run, and I'm going to leave it unimplemented for now. And the way layers are plugged into a Zio application is by writing a program, so val program, as a for comprehension, where we compose Zio effects, and I'm going to yield unit after the for comprehension because I don't care about the value that we return after the Zio effect. So I'm going to try to run a subscription, but based on a service which we obtain after Zio service. Now I'm going to import Zio everything so that I have access to the entire Zio API. So once I have a Zio service of type user subscription, then I can use this service to call its API. So I'm going to say, for example, taken from the explicit DI, I am going to say, I'm going to actually cut these two lines and paste them here. So I'm going to run some effects that will say subscribe on user Daniel and user Martin based on this service. So what I'm going to say is underscore in, and because the subscribe function may produce side effects, I'm going to wrap that in a Zio attempt with subscribe. So I'm going to say service.subscribe. And then I'm going to yield unit. Obviously, if somebody gives me a user subscription, then I can use that to subscribe user Daniel and user Martin. Now, in my override def run, which is my main application, I can say program, which is a Zio effect. So this program is a Zio effect that produces unit. It may fail with a throwable, but it requires a user subscription. This is what the first type means. And in order for the run application to be fully defined, I have to provide instances of user subscription. So I'm going to say program.provide, and the ZLayer feature of the Zio library allows me to provide or pass instances of everything that can be used to create a user subscription as a Zio layer. So here's what I'm going to do. I'm going to create an object, user subscription, object, user subscription. I'm going to define a val called layer, and this is going to be a ZLayer.from function that creates a ZLayer instance that, given some arguments, it can create an instance of user subscription when provided as an argument to the provide method. So when this Zio effect is instantiated, it will be injected with all the requirements necessary to run that effect. And this is defined in terms of a ZLayer. So ZLayer from function, I'm going to say user subscription, with underscore and underscore because the email service and the DB are arguments here. So this is going to be a ZLayer that produces a user subscription when evaluated, but it requires an email service and a user database as the first type parameters. Now, obviously, the Zio library will take care to pass those type parameters naturally, but I'm going to have to provide layers for the other services as well. So for example, here, if I say program.provide, I'm going to say user subscription.layer. I'm providing a layer of type user subscription, but this also gives me a compiling error that I need now an email service and a user database in order to be able to build that user subscription correctly. So I need to be able to create layers for the other dependent services as well. So email service, and I'm going to have a val layer as ZLayer dot, and I don't have any dependent parameters here for email service. So I'm going to say ZLayer succeed with email service like this. And I'm going to pass email service dot layer as the second argument, and the compiling error has changed. Now I need a user database. So I need to do the exact same thing for the user database. So object user database, I'm going to have a val layer as ZLayer dot, and I need ZLayer from function because I'm taking an argument here. So ZLayer from function user database underscore. So this is going to be a ZLayer that produces a user database as required, but it requires on its own a connection pool. So I need to go one layer down. So I'm going to say object connection pool, and I'm going to have a val layer. And this time I'm going to say ZLayer succeed with connection pool with the number, let's say 10, with 10 connection instances. All right. Obviously, this can go way further with values fetched from configurations, which can themselves be layers and so on and so forth. But at this point, what we have is layers in the companion objects for all dependent services, which allows me to write user database dot layer and connection pool.layer. Now, what the ZLayer feature in the ZO library allows us to do is provide these instances or these layers in whatever order we want. And by virtue of macros, the ZO library will take care to fetch a graph of dependencies between all of these instances and inject the necessary instances in the correct places. Now, this is done via a pretty complicated mechanism based on macros, and Martin Odersky was curious if a simpler solution was possible, which I'm also curious what you think because I'm going to show it to you. And this technique is courtesy of Martin Odersky. I'm sharing this, obviously, with his blessing. So here's what I wanted to show you. I'm going to have my automatic dependency injection here. And ideally, what we would like to do is instantiate all the dependent services as automatically as ZO did, but without the complicated machinery necessary for that instantiation to work. So ideally, what we would like to do is to say something along the lines of, and I'm going to compare that with the explicit DI. So I'm going to have a main function. I'm going to have a val subscription service as a user subscription. So no ZOs, no wrappers, nothing. I would like to create a magical method like provided or summon or something like that of type user subscription. And this should magically trigger the dependency injection mechanism where we will fetch all the necessary instances to be able to build a user subscription, obviously lazily, all right? And then the rest of the code should be identical, no wrappers, no effects, nothing else, all right? So ideally, we would like to be able to build a magical method that creates a user subscription automatically given the presence of the necessary instances, and this mini framework should take care to pass all the instances automatically in the right places without us having to specify that explicitly in each place. So how would we build such a thing? So Odersky had this very ingenious idea. I'm going to create an object. I'm going to call this providers. And I'm going to have an opaque type. So opaque type alias. I'm going to call this provider A. And this is going to be the same as an A. Now, with the opaque type, we can create providers of instances, which are themselves instances. So this is a zero-cost wrapper. And the provider is something that specifies the fact that this is meant to be injected in some place. And I want to expose two methods. One, to provide an instance, so provide A with a value of type A. And this turns the value into a provider. So I'm going to say provider A, and that is the value. And then want to extract a value out of a provider. So one, to provide dead. So provided A, using, and here is what I'm going to use here. I'm going to use an implicit or a using clause, using P as a provider A. And this is going to be an A, and obviously because the provider A is the same, I'm going to return P, okay? And here in automatic dependency injection, I'm going to import providers. So if this method worked, I should be able to obtain an instance that I require. Now, in order for this to work, we need a given. So we need givens of the appropriate types. So if somehow I could create a given of user subscription automatically, then that should take care of my provided method. Now, obviously, it's very tempting to create a given of type user subscription somewhere, like in the companion object of user subscription, and just be done with it, but that's beside the point. You're still creating the user subscription manually. We would like to be able to automatically derive an instance of user subscription automatically depending on the types that we pass as a parameter. So what Martin Odersky ended up doing was to change the signature of the constructor of the service that we wanted instantiated. So here we would be the user subscription. And instead of taking these two values directly as a parameter, we would have a using clause, a provider, using provider of a tuple, email service, and user database. Now, in this case, our code is going to break, and I'm going to cut out the ZODI. So I'm just going to collapse that. And I'm also going to cut out the layer here because it doesn't make sense anymore. And I'm going to import providers, assuming this sat somewhere else in some sort of library. And in the body here, we would say instead of email service and DB, would say provided of type, in this case, email service, and in the other case of user database. So user database. And we need to be able to add some functionality to the provider's mini library in order for us to be able to extract a provider of email service and a provider of user database given a provider of a tuple. So assuming that this would work, we need to go back to our provider's mini library, and I'm also going to cut out the explicit DI because this example also doesn't work. Okay. Right. Now, in my providers thing, I'm going to add a little function or a little given to be able to extract multiple instances based out of a provider of a tuple. So I'm going to have a given, and given a tuple, which is a tuple, and a type parameter a. So assuming that we can find a provider of t, which is the tuple, and also the ability to tell whether the type A is in the tuple, and that's a bit of a more complicated type level programming thing. So I'm going to leave a space here, can find A in tuple. I should ideally get an A. And I'm going to leave that with question marks for now. Now, if this thing worked, then all I should be able to say wherever I use the provided method, I'm going to say given provider of type user subscription as provide with user subscription, like this. And then the compiling error is going to tell me the thing that I need, which is I need a provider of email service and user database. So I should be able to create providers of email services and user database as well. So I'm going to say using provider of connection pool, provider, and I'm going to say provided with connection pool. And I'm going to import providers. All right. And in the companion object, I'm going to cut the ZLayer because that doesn't work anymore. And in at my usage site, I'm going to have my given provider of email service as provide with email service, like this. The compiling error still tells me that I need user database. So I'm going to say given provider of user database as provide user database, and a given provider of its own dependency, which is connection pool, as provide with connection pool with number 10, if I remember correctly. And in this case, the provider of user database is fully satisfied, and that's because the connection pool acts as a dependency for user database. Now, as for user subscription, I need to automatically be able to inject the right instances, which is email service and the user database, as implicit values, which means that I also need to have a given, so a given, and I'm going to have a type A and a type T, which is a tuple. And assuming that I have providers of A and providers of T, then I should be able to create automatically at the type level a provider of the tuple A plus T. So using provider of A and provider of T, then they should allow me to create a provider of the tuple A, and the concatenation between A and T at the type level is *:T. So this is very similar to shapeless, most of which was integrated into Scala 3. So assuming I can do that, then the library allows me to automatically create and automatically inject the right instances of user subscription, email service, user database, and so on and so forth. In other words, whereas in the previous examples with Zio, I used to create layers of type user subscription, email service, user database, connection pool, and the library took care of wiring the dependencies automatically. Now I'm using the Scala type system to wire all these dependencies automatically because at this point I'm creating the layers. So these are all my layers, and the type system, so type system injects instances automatically. So all I need to write assuming that this providers thing was a separate library, all I needed to write was like 4 lines of code for all the instances that I needed to write, and the instances are injected automatically. Now, Martin Odersky also came with a potential implementation of this providers library. It's not long at all. It's like a few dozen lines of code, and it does everything perfectly, automatically, without any complex machinery. So in what follows, I'm going to show you how these things are possible. So what we need is these two givens. Given a tuple, I need to be able to extract an A if it exists. So I need to be able to return it. And the reverse, given a provider A and a provider of a tuple, which is a T here, I need to also be able to create a provider of the composite tuple A and T. Now, the second method is far easier because the Scala type system allows us to convert between types and values much easier. So using P as a provider A and PT as a provider T, I can combine these two together into a composite tuple, P star colon PT, and that's it. This is the given. So if I have a provider A and a provider T, I can very easily create a provider of a composite tuple. And I should also be able to start from somewhere, which is the given for a provider of the empty tuple. So given provider of empty tuple, and that's the empty tuple. In other words, if I have the email service and the user database as separate instances, I should be able to create a provider of a tuple email service and user database as required by user subscription, because look at its constructor argument. It uses a provider of the tuple email service and user database. And the tuples are swappable because due to this given, if I have two values, let's say email service and user database, because of this given, I can create two providers, email service and user database in the tuple, and user database and email service as the other tuple. So this given allows for all possible combinations of constructor arguments, regardless of what the order you used in the constructor of the original service. Okay, so tuples are swappable, and this is given by this given, just to make another pun. So swappable, tuples included. So all we have to do is create the first method. Now, the first method is a little bit more complicated. And if you've ever watched one of the type-level programming videos on the Rock the JVM channel, then this technique will prove very, very useful because I'm going to use some of those techniques. So given a tuple and a value A, using a provider of the entire tuple, I need to somehow extract the value A out of that tuple, assuming that the value A can be found in the tuple. How am I going to express that? Well, I'm going to express that in a separate trait, and I'm going to store that trait in another object. I'm going to call this type-level programming, so TLP. And I'm going to express that as a trait. I'm going to call this select. And select takes two type arguments, a tuple, so T is a subtype of tuple, and the value of type A. And this has an apply method that takes a tuple, T of type tuple, T of type T, and returns an A. So this is the trait. So I'm going to assume that there exists a select instance for a tuple. So there exists a select of T and A. Now, in order to make the compiler happy, I'm going to import TLP star. And I'm getting an IntelliJ error, but I'm pretty sure that the code does compile. So we have no given instances, which is a different error, and that's okay. So I'm going to get back. So user subscription is on its own, and this is okay. So IntelliJ gives me a highlighting error here. Okay, so assuming that I have a select and a P, I'm going to call this P as a provider T and select as a select TA. The value of type A that I want to extract out of that is select.apply on the provider, like this. In other words, this select trait has the ability to extract a value of type A out of the tuple T. How we're going to build that? Well, that's a problem that we're going to solve shortly. So in other words, if we have a provider of a tuple, we need to be able to extract the correct value of type A out of that tuple if that thing exists. And the way that we can make sure that the type A exists in the tuple is by type-level programming, which is the subject of this particular section. Okay, so I'm going to build some givens that will guarantee the fact that either the type A exists in the tuple and I can extract the value out of that tuple, or it doesn't exist at all and the compiler will give me an error. So what I'm going to do is create a given, and I'm going to have a type T, which is a subtype of a non-empty tuple. So non-empty tuple, and the type parameter A, using the ability to find the index at which the type A exists in the tuple. For example, if I have the tuple int string list int, each type will have a position inside the tuple, and we can find the index of the type in the tuple using a little operator that I'm going to express as a type. So I'm going to say type index of, and I'm going to have a T, which is a tuple, and a type A, and this is going to be an int. And because of Scala 3 features, I can use a type match. So I can say T match, and in case we have A star colon anything, so it starts with A, then I'm going to return 0, like the type 0, but it's expressed as the number 0 as well. And in Scala 3, types and values, numerical types and values are also interchangeable, which is going to prove very, very useful. And in case we have anything else with some sort of rest of the tuple, I'm going to have successor, which is denoted by the type S from the compile time package. So I'm going to import compile time ops int, and there are a bunch of operators at the type level, and S is the successor of a natural number expressed as a type. So the successor of index of RT, which is the rest of the tuple, and A. So in this case, index of the type int string list string. So this is the first type argument. And the second type argument is string, is the number 1, or the type expressed by the number 1. So index of these type parameters, first is int string list string, and the type string is number 1. Now, numerical types and numerical values are also interchangeable, which is going to prove very, very useful here for the given that I want to extract. So given a T, which is a non-empty tuple, and an A, using, and I'm going to have index of, and then I'm going to have a T and A. Let's call this index. This is going to give me back a select. So a select that can extract the value of type A out of this tuple. So a select of type T and A with def apply is going to take a tuple of type T, and it's going to give me back an A. Now, I'm going to use this index via a separate type in the compile time package, which is called value of. I'm going to wrap this around, and I'm going to say tuple apply at index value. So tuple apply at index value is going to give me an any. So this is going to give me back an lm of this and type whatever. So I'm going to cast it. So as instance of A. And this is the select instance that I'm going to obtain. I think I have some compiling errors here because I've swapped the operators here. So if I have a non-empty tuple where the type A exists due to the existence of index of TA by this type, then I'm going to automatically make the compiler create an instance of select TA where the apply method is going to extract the value out of that tuple at that particular index. Now, this is a bit of sci-fi, but at this point, we should be in the clear because at this point, we can extract a value out of that tuple if the value exists in that tuple, guaranteed by the compiler due to the structure of the types given by all of these givens. So at this point, the compiler should compile our code, except we don't have provided instances here. And that's because in the provider's library, even though we have this highlighting error here, I'm not going to extract a value of type A, but I'm going to extract a value of type provider A. So if I have a provider of tuple and a select of T and A, I should be able to give me back a provider A. And at this point, the code should compile. So the code compiles without any issues, even though IntelliJ gives me back some highlighting errors. And in this automatic dependency injection application, I should be able to run this. So look at that. We have welcome Daniel and welcome Martin subscribed to our subscription services, given the fact that we declared the layers at some point in the application and let the type system inject the values automatically in the right places. With this very small library between TLPM providers, we have pretty much less than 50 lines of code. Okay, so without any complicated machinery, we are able to inject the right instances in the right places just by looking at the types. So this is pretty elegant, and it removes the need to adhere to any sort of additional machinery like ZIO or an effect system or any other external API. You just create your givens, you mark them as provider of your right type, and then the mini library will take care of that for you. The only thing that I don't really like about this approach is the fact that I have to change my constructor to, say, using a provider of a tuple. I would like to be able to inject these instances without having to change how my services are being constructed. So I'd rather have the old constructor and create these providers automatically for me, which is why I'd rather organize this a bit differently. So I'd say I'm going to have my email service as an email service and user database as user database like this. And instead of provided whatever, I'm going to remove that. So I'm going to say email service. So email service and my user database as before. So this is my regular Scala code. I don't have to change my instances, but I can create my provider here in my user subscription. So I'd have to create, instead of a layer in the form of a ZLayer, which by the way, now it works again, I'm going to have a val provider as a given. So given provider as a provider of user subscription. And this uses, so using, a provider of the tuple. So provider of tuple email service and user database like this. And this is a call to provide with a user subscription where I'm going to extract email service and user database as provided. So email service and provided with user database. And I'll let the type system extract these values for me. Okay, so that's one companion object. In email service, I'm going to have a given. So I'm going to have my provider here, boom, like this. Then in the user database, I'm going to get back to the layer because now it should work if I can remove the provider as constructor arguments. So I'm going to have con pool as connection pool. And I'm going to use that. So con pool.get. Okay. And in the companion object of the user database, I'm going to have a given like this. And given provider of user database using provider of connection pool. And this is going to be provide user database with provided connection pool. Boom. So that's going to be one. And then in the connection pool, I'm also going to work in the companion object, and I'm going to move this given inside like this. And I'm going to remove all these layers constructed manually. So at the usage site, I shouldn't have to care about layers at all, and the code should still compile. So if I hit compile, it should still work. Look at that. We have users subscribed to our fictitious newsletters, given the fact that in the companion objects, we have the right providers of the right types. So all we care about is to say provided of the right type, and the type system will take care of everything else for you. So I hope you like this little technique for automatic dependency injection. I also showed you how you can build such a mini library using just Scala's type system to automatically inject the right instances in the right places of the right types. Let me know in the comments what you think of this technique. Both Martin Odersky and I are both curious to see what you have to say about this organization. I hope you liked this video. If you did, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. And check out my website at rockthejvm.com. I have literally hundreds of hours of pretty much everything you need to know about Scala functional programming and all major libraries and tools. Until next time, folks, this is Daniel signing off.